everyone. In the last video, I have reviewed the concept of elasticity, namely the four types of elasticity: a PED, price elasticity of demand; OID, income elasticity of demand; income supply elasticity, as well as cross price elasticity. So in this video, I will discuss few example. The first one that I borrowed from this book, Edward Dowling, and I'm going to consider this example 6.18. So we are given a demand function Q equals to 700 minus 2p plus 0.02y, where p refers to price, this is price, and y refers to income. And both the value of price and income are given as well, and we need to find the price elasticity of demand as well as income elasticity of demand. So let's write the formula of price elasticity of demand. In the last video, I'm sure you can recall the formula, which is del Q by del P times P by Q. So I need three values, del Q by del P, P and Q, to find epsilon D, which is the price elasticity of demand. P is given, so I need to find the two other values, Q and dQ by dP. So Q should equal to 700 minus 2P. So P is 50, P is 25, my bad. So I can insert that value 25 plus 0.02 y is 5,000. So if I use the calculator, 5,000 times 0.02 is 100. So for the time being, I'm erasing this one. I need more space. So 700 minus 50 plus 100. So 800 minus 50 should be 550. Now I need the derivative of Q with respect to P. For that, I need to take the derivative of this function, which is 700 minus 2p plus 0.02y. Interesting thing is that if you remember the previous video of partial derivative, we have discussed about the situation where you have more than one independent variable. We have similar situation here where Q depends on price and income. So if the price changes, we're assuming there is no changes in Y. So we're considering Y as constant. So if that is the case, here we are considering only changes in P, and Y should be considered as constant. So eventually the derivative of this and this should be 0. This is constant 700, of course, and this is constant as well. So minus 2p with respect to P should be minus 2. Now if I insert these values in the formula, negative 2 times P is 25, Q is 750, so 50 by 750. If I use the calculator, 50 by 750, 0.02 0.066, and which is less than 1, and that all it matters. So when elasticity of demand is less than 1, we can call that inelastic demand. So demand of this particular good is inelastic, and we can call Q is a necessary good. Now let's consider price elasticity of income. I have already done that example, but then again we can do it for your convenience. Alright, so I'm sure you remember from the last video, YD, this is the formula of YD, which is epsilon y equals del Q by del Y times Y by Q. So again I need these three values, del Q by Y, Y and Q, to find epsilon Y. Two values are already found. Y is given, so Y equals 25. We just found Q equals 750. You can see here Q is 750, and now we need to find dq by dy. Again, if I take the derivative of dq by dy with respect to, my bad, it's 2p plus 0.02y, then we're going to consider these two as constant. This is of course constant, and we need to consider price as constant as well. So derivative of these two terms should be 0, and the derivative of 0.02y should be 0.02. So if I insert these values here, 0.02 times y is 5000 and q is 750, we have 100 over 750, so it's positive. That all it matters. And when elasticity of income becomes positive, from the previous video or from equal to 1, I'm sure you remember, we can call this product as normal good. That means when there is any change, any increase in price, quantity demand will increase, and when there is any decrease in income, it will lower the demand for that good. Alright, so I think you got some idea how to solve this type of problem. Now let's take a bit different example. Not different, it's a bit complex example. So in this example, we have two goods, P1, two goods, and the prices of two goods are given. Also income were given. So in this demand function Q1, you can clearly see that Q1 equals to 4850 minus 5 P1 plus 1.5 P2 plus 0.1 Y, where P1 is the price of good 1, P2 is the price of good 2, and of course Y refers to income. And we need to find the price elasticity of demand, income elasticity of demand, and cross price elasticity of demand between good 1 and good 2. And there will be another question. I will come to that later. So let's find the price elasticity of demand. Again, I'm sure you remember the formula of price elasticity of demand. This is del Q1. Here we have Q1 instead of Q. That's why I have written Q1. And I need to find the price elasticity of demand. So I need to consider the same goods price, which is P1 times P1 by Q1. P1 is given. I need to find the value of Q1. So 4850 minus 5 times 200, this is the price of P2, plus 1.500, this is the price of P2, and let's go that way, 0.1 10,000. So 4850 minus 1000 plus 150.1 of 10,000 should be 1000. So these two should be cancelled out, and if I add 150 with this one, this should be 5,000. You can use calculator if you wish to do that. Anyways, so now I need to find the derivative of Q1 with respect to P1, and again I need to find the partial derivative, because in this case Q is a function of P1, P2 and Y. So if I consider this demand function, this 4850 is a constant. I need to consider P2 as constant and also Y as constant. So the derivative of these three terms should be 0. So if I just take the derivative of minus 5P1 with respect to P1, this becomes negative 5. And all these three terms derivative should be 0, as the derivative of a constant is 0. Now if I insert these values, negative 5 times P1 is 200 and Q1 is 5,000. So 1,000 by 5,000, this is 1.5, and this is less than 1. So again, this is inelastic demand, and Q1 is a necessary good. Now let's find the income elasticity. So income elasticity is YED this is derivative of Q1 with respect to Y times Y by Q1. We already know Y equals to 10,000 and Q equals to 5,000. All I need to find is this dQ1 by dy. So derivative of Q1 with respect to Y. Again, if you take the derivative of Y, I need to consider P1 and P2 as constant. If I do that, all these derivative, all three terms derivative should be 0. So in other words, I have 0. My bad, 1. Now if I insert the value here, 0.1 times y is 10,000 and q1 is 5,000, it should be 0.2, which is positive. So we know that if the income elasticity is positive, then we have normal goods. All right, so that's pretty straightforward. Now let's find the cross price elasticity between good 1 and good 2. We can write XCD, the formula, which is epsilon 1 and 2, because we have two product 1 and 2. So in this case I need to find the derivative of q1 with respect to p2 times p2 by q1. We know the value of p2 and q1. All I need to do is to find the partial derivative of q1 with respect to q2. So again, if I do that, all these three terms should be 0, and we have 1.5 p2, so this should be 1.5. Is this exactly the same way we did the other two? I'm not mentioning it here. So if I insert these values, 1.5 times p2 is 100, p2 is 100, divided by q1 is 5,000, so 150 divided by 5,000, and we have a positive number. So if the cross price elasticity become positive, we know that it's only possible when goods are substitute in nature. So good 1, the relationship between good 1 and good 2 is a substitute in nature. Now finally, cross price elasticity between good 1 and 3. Do I have 3 here? No, so I don't need to find the cross price elasticity. All right, so in this question I need to find the PD, YD as well as XCD. We have found all three values. Now let's find the second question, which requires us to determine the effect on good Q1 of a 10% price increase for good 2. So if you remember the definition of cross price elasticity, which is percentage change in Q1 over percentage change in P2. So in the question I need to find I need to determine the effect on Q1, percentage change in Q1 due to a change in 10% change in price increase in P2. So in other words, percentage change in P2 is 10%. It's increase, so it should be this. If it's a decrease, then it should be -10 or -0.1. We just found that epsilon 1 2 is 150 by 5000. So if I cross multiply, then percentage change in Q1 should equal to epsilon 1 2 minus percentage change in P2. So if I just multiply these two numbers, 150 by 5000 times 0.01, I should get 150 by 5000 times 0.01, my bad, 150 by 5000 times 0.1 times 100 is a 0.3%. So if there is any increase, 10% increase in the price of good 2, this will increase the demand for good 1 by 0.3%. Hope you get the answer of these two questions correctly. And if you wish to practice, you can do it from the same book. Let me give some time to find the numbers. This is 6.18, 6.19, 6.20, and 6.21. So 6.18 to 6.21 from Dowling's book, you can practice similar maths. Thank you so much.